This section looks at the high-level processes to prepare data as it is ingested into an analytics pipeline. Regardless of when data is transformed, the data engineer needs to develop methods to extract and combine disparate data sources into a useful data set. Data analysts and data scientists need to explore data, test hypotheses, and determine how to enrich or modify their data set to meet their business needs. The term data wrangling reflects the complexity and messiness of transforming large amounts of unstructured data or sets of structured data with multiple schemas across multiple sources into a meaningful set of data that has value for downstream processes or users. The content in this module takes the perspective of the data engineer. However, data engineers, data scientists, and data analysts might each perform different types of wrangling based on what they need from the data and the state of data that they start from. For ML applications in particular, a data scientist might perform lots of iterative wrangling to get a data set that is suitable for building and training an ML model. The Elements of Data module introduced this slide to illustrate how an organization might combine different data types to create a personalized customer experience. The organization can combine customer data from the on-premise database with public health data to personalize information for a patient. Patients might have a mobile app that sends real-time data that could be used to alert the patient or their doctor of a potential issue. With the data available, data scientists can build machine learning models to provide personalized predictions. As the data engineer, you need to figure out how to pull all this data together and make it available in your pipeline. This slide presents the steps of data wrangling as distinct. In practice, there might not be clear delineations between the steps, there might be iterations within and across steps, and individual steps might not occur as part of ingesting a data source into the pipeline. Each step might be more or less complex depending on the goal of the specific ingestion that you're working on. The ingestion and data wrangling process could be as simple as opening a source file in Microsoft Excel, manipulating columns and values in a spreadsheet, and then manually checking the validity of the data, and then saving it as a CSV file and uploading it to pipeline storage. At the other end of the spectrum, complex transformations might be needed to support high volumes of incoming data for an ML application. The data engineer and data scientist might use a variety of scripts and tools to wrangle the data for that kind of use case. As illustrated on this slide, the steps of data wrangling generally coincide with the steps of ETL processing. However, it's worth making a distinction here between ETL processing and data wrangling. Traditionally, ETL processing has been more of the data engineer's domain. ETL encompasses scripting transformations within batch jobs that run on infrastructure that's controlled by IT. Analysts and data scientists worked only with data that was in a defined consumable state. Data wrangling is more associated with an ELT flow, where business users or data scientists transform data sets that are available to them within the pipeline storage layer, but that haven't been refined for a specific use case. The continuing trend in cloud tools and services is to provide more types of users with direct access to extract and transform data. A data engineer must be able to build complete analytics pipelines and transform data as needed for a use case. But it's also important to stay aware of tool updates that can provide their team's analysts and data scientists with more autonomy to work with available data. It's important to remember that the defined layers help to describe the activities that are performed and tools that are used as data moves through and is transformed in the pipeline. But pipeline activities are iterative within and across layers. Each pipeline's architecture might look quite different depending on the business problem being addressed, the type of data being ingested, and even the skills and expertise of the team that supports the pipeline and accesses the data. This diagram is derived from the Modern Data Architecture in the Design Principles and Patterns for Data Pipelines module. The diagram illustrates an ELT flow and highlights how the data wrangling steps might occur. In this reference architecture, data is ingested into a storage layer that includes Amazon S3 as the data lake and an Amazon Redshift data warehouse. Within the data lake, S3 buckets are used as named zones to store data in different states. The landing zone bucket serves as temporary storage from which you perform just enough cleaning and validating to permanently save the ingested data into the raw zone bucket. You can then use data in the raw zone for additional use cases. This data might be structured, semi-structured, or unstructured. At this stage, the initial extract and load steps are complete. In this example, the transform part of VLT occurs when data in the raw zone of the data lake is transformed into a highly structured state that the Redshift data warehouse can use. The data engineer or scientist would need to structure, enrich, and validate the data before the warehouse can use it. Data is stored in different zones as these steps are performed. Data structuring prepares the data for the trusted zone. Then data enriching is performed on data in the trusted zone, modeling the data so that it can be joined with other data sets and stored in the curated layer. Data validation would also occur as part of these transformations before storing data into the next zone. Data sets in the curated layer are ready for the Redshift data warehouse to ingest. If the process to load data into the data warehouse had been accomplished using a traditional ETL flow, the same wrangling steps would still be needed. However, all the transformations would have been performed on the data in a temporary staging location before the data was loaded directly into the data warehouse. Users would not have access to the data until processing was complete, and the raw data would not be available. The next section looks at each of the steps in the wrangling process in a bit more detail. Here are a few key points to summarize this section. Data wrangling is a multi-step process with steps that overlap and iterate differently depending on the data source and the use case. Data wrangling steps include discovery, structuring, cleaning, enriching, validating, and publishing.